Do you know what are quadratic equations, how they are formed, and what are they used for? You will get the answer to all these questions in this session.
This is awesome!
So let's start by understanding how an equation is formed. Think of any polynomial, for example x square minus 5. Now if I put equal to 0 with it, I get an equation. Simple. This is called a polynomial equation. So if p of x is any polynomial in x, then p of x equal to 0 is called an equation. For example, x square minus 5 equal to 0, or 7x raised to power 4 minus 6x square plus root 2 is equal to 0. Understood? Now what is a quadratic polynomial? You already know that a polynomial whose degree is 2 is a quadratic polynomial, and its standard form is ax square plus bx plus c, where a is not equal to 0. So in standard form, a quadratic equation is of the form ax square plus bx plus c equal to 0, where a is not equal to 0. Why so? Because if a becomes 0, then the x squared term will vanish, and so it will no more be a quadratic equation. So now can you write some quadratic equations? Like 10x square equal to 0, 15x square minus 7x plus 5 equal to 0. If you are given an equation, then how can you check whether it is quadratic or not? For this, we have to simplify the equation and bring all the terms to the left hand side. Then by comparing it with the standard form, we can easily tell if it is quadratic or not. Let's try out this. Now in this equation, we have x in the denominator, which should not be there in a polynomial. So to remove it, you may take LCM of the terms on the left hand side. Or let me tell you an easier method. Just multiply each term of the equation with this denominator x. And we get x into x square minus 3 upon x into x is 3 equal to x square into x, that is x cube. Now bringing all the terms to the left hand side, we have minus x cube plus x square minus 3 equal to 0. Do you think this is quadratic? Of course not. The degree here is 3, right? Let's take another example. Remember that in a standard form there are no brackets, so we must simplify the brackets first. So by using the identity a plus b whole square equal to a square plus b square plus 2ab, we get x square plus 1 plus 2x equal to 2x minus 6. As 2x is added on both the sides, we may cancel it, and so we are left with x square plus 1 plus 6 equal to 0, or x square plus 7 equal to 0. The degree here is 2, so it is a quadratic equation. Now solve this one. We will first open the brackets. So we get x into second bracket minus 2 into second bracket equal to x into second bracket minus 1 into second bracket. Multiplying further, we get these terms. As x square is added on both the sides, we can cancel. Now add the like terms, and finally on bringing the terms from one side to the other, we get minus 3x plus 1 equal to 0, which is not quadratic as the degree here is 1. Now try this one yourself and then check the answer. So finally we get x square minus 11x plus 8 equal to 0, which is clearly quadratic. Now in this one we have to use the formula x plus y whole cube, which is equal to x cube plus y cube plus 3x square y plus 3xy square. So using this we get x cube plus 8 plus 6x square plus 12x and 2x cube minus 2x on the right hand side. Bringing the terms to this side, and adding the like terms, we finally get minus x cube plus 6x square plus 14x plus 8 equal to 0. It has degree 3, so it is not quadratic. You have been using algebraic equations to find solutions of real-life problems like age of a father and a son, or two numbers whose sum is given. Sometimes we come across real-life situations which can be represented by quadratic equations. So we need to understand how to form and solve these types of equations. Today we will only discuss how to form quadratic equations. So let us take the following situation. First, you need to understand that we have to use only one variable here, unlike linear equations in two variables. So you must find the relationship between the two unknown quantities. Now in this situation, area depends on length and breadth. So these are the two unknown quantities. How are they related? This statement tells us that length depends on breadth. So we can take the breadth as x, and so length is 1 more than twice the breadth, so it will be 2x plus 1. Area of a rectangle is L into B, so we get L into B is equal to 528, or 2x plus 1 into x is equal to 528. Opening the brackets and simplifying, we get the equation 2x square plus x minus 528 equal to 0. So this is how we can represent this situation mathematically in the form of quadratic equation. Consider another situation where we have two consecutive positive integers. As consecutive integers are separated by a difference of 1, we can take the two integers as x and x plus 1. Product is given 306. So x into x plus 1 is equal to 306, or x square plus x minus 306 is equal to 0 is the required equation. Let us try another type of situation where ages are involved. As you can see, mother's age depends on Rohan's age. So we will take Rohan's present age as x years, and so mother's present age will be x plus 26. Now the relationship between their ages is given after 3 years. So let us find out the ages after 3 years by adding 3 to each of them. According to question, their product after 3 years should be 360. So we get this, and on simplifying it, we have x square plus 32x minus 273 equal to 0. In the next question, distance is remaining same and time and speed are being compared. Let us take the initial speed of the train as x kilometers per hour. Time is equal to distance upon speed. So time taken by the train with the speed x kilometer per hour will be 480 upon x. The speed in the second case will become x minus 8. Time taken in the second case will be 480 upon x minus 8. Clearly 480 upon x minus 8 is greater than 480 upon x. Now the difference of times in the two cases is given 3 hours. So we have 480 upon x minus 8 minus 480 upon x is equal to 3. X being in the denominator, we will have to remove it by taking LCM on the left hand side. So we have x into x minus 8 as the LCM, and we get this. Now cross multiplying, we get this, and bringing various terms to the other side, we finally get x square minus 8x minus 1280 equal to 0. So you must have understood now how to represent the daily life situations as quadratic equations. An interesting fact about these is that we can also represent these situations as linear equations by using two variables, but for now we will only focus on quadratic equations. Next, we will discuss how to find the solution of these equations, for which please stay tuned for the next video. Till then, take care and do support me with likes and subscribe. And don't forget to comment if you have any question or suggestion.